Hello everyone, my name is Anya de los Reyes.
Hi everyone, my name is Keana.
Hello, I'm Kerby.
Hello everyone, my name is Bliss Aubrey Villacarlos.
And I am Ahdessa Perez.
And we are the Bliss. For today's vlog, we are going to talk about Chapter 6, Broken Symmetries of Ian Steward's Nature's Numbers.
A mathematical concept as well as an aesthetic one, and it allows us to classify different types of regular pattern and distinguish between them. In Chapter 6 of Ian Steward's Nature's Number, he discussed how symmetry of nature and mathematics symmetry itself contradict ideas.
Steward stated that symmetries are images that correspond with each other. Well, there are different kinds of symmetries. The first kind of symmetry is reflection or bilateral symmetry, which is also known as line symmetry or mirror symmetry. It states that if there exists at least one line that divides a figure into two halves, such that one half is the mirror image of the other half. Second is the rotational or radial symmetry, in where similar parts are regularly organized around a central axis, and the pattern looks the same after plenty amount of rotation. And lastly, translational symmetry. It is a particular translation of an object to another location where it does not change its pattern.
Great physicist Pierre Curie with his wife, Marie, claimed a general theory that effects are as symmetric as their causes.
However, the universe is full of effects that are not as symmetrical as their causes, and the reason for this phenomenon is known as spontaneous symmetry breaking. Spontaneous symmetry breaking is a spontaneous process of symmetry breaking by which a physical system in a symmetric state ends up in an asymmetric state. In addition, symmetry of an object or system is any transformation that leaves it invariant.
Did you know? A perfectly flat pond can develop into series of ripples without any obvious cause. And this important oscillating reaction was came upon by a Russian chemist, Belousov, year 1951. Their discoveries are known as Belousov-Zhabotinsky, or also known as the Bezier reaction. The Bezier reaction makes it possible to observe development of complex patterns in time and space by naked eye on a very convenient human time scale of dozens of seconds and space scale of several millimeters. It can generate up to several thousand oscillatory cycles in a closed system.
The mathematics of symmetry breaking unifies what may seem to be disparate phenomena. The mathematical principles of symmetry breaking are any system with the same symmetry can flow across a planar surface creating patterns. According to Steward, this universality of symmetry breaking explains why living and non-living systems have many patterns. Life itself is a process of symmetry creation, of replication.
Ending the chapter, Steward stated in his Chapter 5, the symmetries of Maxwell's equation. Every one of the four central powers become bound together that is symmetrically related to overcoming the early universe. This symmetry of the early universe is broken in our own universe. In short, there is an ideal mathematical universe which all of the fundamental forces are in perfectly symmetric manner, but we don't live in it. In conclusion, nature has symmetries at every scales. The role of mathematics is to describe symmetry breaking processes in order to explain in a unified way the fact that the patterns we see. Broken symmetry is fundamental to everything, as it acts as an aid for understanding science, especially physics and math itself. If the law of nature were not symmetrical, there would be no hope of ever discovering the complexities of the universe.